This video will cover section 2.8 part 2, and this part is on the composition of functions. So composition of function involves placing one function inside of another function to create a new function. So if you'll think back to when we first started talking about functions and filling in values for functions, and also in the first part of section 2.8 we did this same thing. Remember that if I see f of 2, that means to take the value 2 and put it in place of all of the x's in function f. So when I see a composition of functions, I'm going to use that same principle. But instead of putting a number in x's place, I'm going to put another function in x's place. And so here is the notation for composition of functions. You may see f composite g of x, and that means to take the function g of x. So notice here, instead of a number, I have a function. So I'm going to take the function g of x and I'm going to fill it in to the function f everywhere there's an x. And then if I see g composite f of x, that means g of f of x. So I would take the function f of x. So instead of a number being there, there's a function there. And I'm going to fill it into the function g everywhere there's an x. And so we read this as f of g of x, and then g composite f would be g of f of x. That's how we would read those. Alright, so let's take a look and do a couple of compositions here. Alright, so let's say we have the function f of x is the square root of x plus 4, and the function g of x is 2 over x. What I want to find is f of g of x. I want to find that first. So remember, f of g, or f composite g of x, is the same thing as f of g of x. So instead of a number, I'm going to fill in a function in place of f. So here is function f. It's the square root of x plus 4. But instead of writing the x, I'm going to put g of x. So instead of x, I'm going to put the function g, which is 2 over x plus 4. Alright? That's my function. Now what I want to do is I want to find f of g of 2. So it would be written like this. And I would simply take, and everywhere there's an x, in my new function, I'm going to fill in the value 2. Alright, so then that would be 2 over 2 is 1, plus 4 equals the square root of 5. Alright, also, if I'm given f of g of 2, or written it like this, alright, we know what g of 2 means. Alright, we know that means to take the value 2 and fill it in for x. So if I found that value by everywhere there's an x, replacing it with a 2, I would find that the value of the function g is 1 when x is 2. Now, I can take this value and fill it into function f. So everywhere there's an x, I'm now going to put a 1. So that would be 1 plus 4 would give me the square root of 5. Alright, so either method would work. Alright, either by first finding the composition of f of g of x, which would be this right here, f equals 2 over x plus 4. Alright, and then I fill in my value for x. Or I can find the value of g, substitute that in to f to get my final value. Notice they are the same. Alright, now I want to do the same thing, except this time I want to find g of f of x. So I'm going to take the function f and fill it in to g. So the function g was 2 over x. So instead of writing the x, I'm going to fill in the function f. So it should be 2 over the square root of x plus 4. Now what I want to find is what is the value of that function when x is 5. So now I have a number, I can fill it in for x. That would give me 2 over the square root of 9. 2 over now 3. Alright, or I could have worked it the other way, where I first found f of 5. So I would say the square root of 5 plus 4 would be the square root of 9, which is 3. Then I would find g of 3. So in place of x, I would put a 3. Alright, notice whichever method I use, whether I first find the function g of f of x and then substitute in the value, or I find the value of f, the function f, and fill that into g, I should get the same answer. Alright, let's take a look at another example. Alright, so this time it wants me to find f of g of x. Notice there's no number to fill in, so I'm just going to compose a new function by taking g and filling it into function f. And then we'll look at what type of function we have and determine what the domain should be. So I'm going to take g and fill it into f. Alright, so f is the square root of x minus 1, but instead of writing an x, I'm going to put the function g of x, so 2x plus 5 is taking x's place, and then I say minus 1. So that gives me the square root of 2x plus 4. Alright, I don't have any numerical value to fill in, so that's as far as I can go. I have no input for x, just a new function is all I have. But now I want to find the domain. So remember, for square root, the radicand cannot be negative. So we would say, take the radicand, set it greater than or equal to 0, and solve for x by subtracting 4 from both sides, then dividing by 2, to find that x can be any value greater than or equal to negative 2. So if I write that in interval notation, it would look like this, negative 2 to positive infinity. Alright, now I want to do the same thing, except this time I'm going to fill in f into g. So it should be like this, g of f of x. Instead of putting a value in for x, I'm putting the entire function in for x. So I want to take the function f and fill it into g. So the function g, we said, is 2x plus 5. Alright, so I'm going to say 2, and instead of writing an x, so here's my function g, 2x plus 5, but instead of writing the x, I'm going to put the function f of x, which is the square root of x minus 1. Alright, then if I multiply that out, I'll have 2 square roots of x minus 1 plus 5. That would be my new function. Alright, then to find the domain, alright, I would say, first I need to get my radical by itself, like this. So I'm going to say 2 square roots of x minus 1 was negative 5. Alright, so I'm still going to do the exact same thing. Alright, whether I solve it out or not, let's just do like this. Let's just take all this off. That's way too confusing. Alright, so here's my new function, 2 square roots of x minus 1 plus 5. Still, for the domain, because it is a square root function, I'm going to say radicand must be greater than or equal to 0. Solve for x, I find that x must be greater than or equal to 1. So if I write the domain, it should be bracket 1, comma, positive infinity. So once I get to here, there's really no need to do anything to it to find the domain. I simply say this is a square root function. Whatever's under the radical sign has to be greater than or equal to 0. I take it out, set it greater than or equal to 0, and solve for x. So the stuff I did previously, just ignore that, erase that off your paper, and go with this.